Alrighty, so now how are we using that information? So we're going to take all our 6 trig ratios and we take all these points or other things, and we're going to be using that in the quadrants now. Okay, so we're going to be doing similar things to what we did a couple days ago, but now we're going to venture out to other quadrants. So if an angle goes through the point 3, -4, so it's a good idea to draw these things. So 3, -4, so let's say this is 3 here, and this is negative. Okay, so we're saying that there's an angle here. So it was drawn there, doesn't matter which direction, but it goes through 3, -4. Okay, we want to find all the 6 trig ratios related to that angle. Okay, so that angle is in the 4th quadrant. And what we do is we draw a right triangle to the x-axis, just like we did yesterday, but now we're actually going to find these values. Okay, so this is always our theta, always with the x-axis and the terminating side. Then we have a right angle, and since this was 3 here, this value is 3, and that was -4, so this is 4. Now, we want to find all 6 trig ratios, so we do have to find the hypotenuse. So 3 squared plus 4 squared equals x squared. Some of you may already know this is 25 equals x squared, so x is 5. Okay, so our hypotenuse is 5. So let's just label these, not like that, in an obvious way. So this is the opposite, this is the adjacent, and this is the hypotenuse. Now, I have a way of doing this that is just, I have to do it because I tend to always forget to put my signs on things. So if you put your signs on the 4, you're negative on the 4, and then you do this, it'll all work out for you. I tend to forget to do that, so I do it this way. So sine theta, I have to find all of them. Cosine theta, tangent theta. I always write them like this, so their reciprocals are next to each other. Sine's reciprocal is cosecant. Cosine's reciprocal is secant. And tangent is cotangent. So I just do this, and then I say, okay, I'm in quadrant 4, so cosine and secant are going to be positive, so everything else is negative. And then I don't worry about my signs. If you put the negative on the 4, that's perfectly fine, but don't put the negative, like, don't do it twice. Here I'm doing my signs, and so just stop there, and then just do do all the functions with just the positive values. Okay, so sine is opposite over hypotenuse, so 4 over 5, so it's reciprocal, 5 over 4. Cosine is 3 over 5, and it's reciprocal, 5 over 4. Tangents, opposite over adjacent, 4 over 3, and so it's reciprocal, 3 over 4. All right, so sometimes you have some radicals, but that's the basic idea. You can find all 6. I don't believe I'm going to have you find all 6 all the time, but you could find all 6 at any time. Okay, you can find any one of the 6. So remember what quadrant you're in. I tend to deal with that right away, but if you just want to deal with it as you're going, that's also fine. Okay, that's just the way I'm teaching it. Please don't yell at me. No, I'm just kidding. All right, so now we have this, what we did before. Sine theta is -5 over 3. So it's the same thing that we did before, but it's telling us what quadrant we're in. Okay, so if it was the sign was negative, it could have been in quadrant 3 or 4. But so it's telling me it's in quadrant 3. So now I can determine all my 6 trig ratios. At least their signs. I can figure them out. And I love to deal with those first, so please don't be mad at me. I just deal with them first because honestly, I just have issues with signs. So this is cosecant is the reciprocal, secant, and cotangent. Okay, so I know if I'm in quadrant 3, I know sine and cosine are going to be negative. So are their reciprocals? Beautiful. All right, I also know that the sine is 5 over 13. So I know the cosecant is 13 over 5. Wow, look at that. I haven't even done anything yet, really. All right, so now I have to do something. So now I know that sine is opposite over hypotenuse. So I like to call that, I don't know if I said it before, but a hidden right triangle. This is my theta. So the opposite side is 5. The hypotenuse is 13. So now we can use our Pythagorean theorem. 5 squared plus x squared is 13 squared. And all said and done, you get 12. I don't really feel like doing anything. There are a bunch of Pythagorean triples. 5, 12, 13 is one. 3, 4, 5 is another, where the biggest side is always the hypotenuse. And there's some that just are nice and work out. Okay, so this is our opposite adjacent hypotenuse. So cosine is adjacent over hypotenuse. Secant is the flip of that. Tangent is opposite over adjacent, and cotangent is the flip of that. Okay, so the only one that's positive is tangent and cotangent because we're in quadrant 3. Everything else is negative. Beautiful. All right, last one here. This one isn't so pretty. It's not a Pythagorean triple. All right, but we are in quadrant 2 this time. So knowing that we're in quadrant 2, we know that sine and cosecant, these guys are positive. Pos. Oh my goodness, I can't write. There we go, that's better. Alrighty, so now we can write these out. Sine, cosine, tangent. I'm trying to write faster, but it's making it messier, so I'm sorry. I'll try flipping. Cosecant, secant, and cotangent. Alrighty, so sine and cosecant are positive, so everything else is negative. Beautiful. All right, we know that the cotangent is negative 2 over 3. So the tangent is 3 over 2. All right, we got some nice stuff there. Now we have to figure out the other side. So I am going to do this down here. I'm going to have a slight mess of my hands here in a minute, but whatever. Whatevs. All right, so this is theta. Cotangent is adjacent. So adjacent is on the top and opposite is on the bottom. Okay, so now 2 squared plus 3 squared equals the hypotenuse squared. So 4 plus 9 is 13. So x is the square root of 13. We do not have to take the negative version unless you want to do it and then reject it because, you know, it's distance, so it's not going to be negative. All right, so now we have a slight mess happening in our world. So sine is opposite over hypotenuse, 3 over radical 13, which is super pretty, except the radicals in the bottom, which we don't necessarily like. So then when we flip it, it's not in the bottom anymore. So flip it right away. And then rationalize the denominators where you need it. Okay, so then negative 2 over radical 13 would go here. And flip it, radical 13 over 2. Because if you rationalize and then flip it, you're going to have to rationalize it again. So don't do that. So the sine and the cosine do need to be rationalized. Because they're crazy. They need to be more rational. Okay, so radical 13 over radical 13. These, oh, nothing much happens. That's it. Okay, so the final answer is 3 radical 13 over 13. And then the same thing with this one. But I just have to remember when I'm doing this to take the negative along with me. So this winds up being 2 radical 13 over 13. This is very messy. I should have spread this out a little bit more. And it's negative. So those are all my values. I feel like I need to redeem myself a little here. There we go. That's so much clearer. All right. All right. So that's it. Have a wonderful day.